All right, welcome. I've got a fun one for us today. We're going to start some new slides on objects and classes. Classes is a very, very powerful topic, and it's actually one you've seen a little bit secretly. I'm going to tell you how to make your own in this lecture. All right, but to start, we have to begin at a place called structs. All right, that will lead to a place called classes. So structs are like the baby version of classes. I will define both, but structs are short for data structure, all right, which maybe still doesn't make a lot of sense, but that's where the struct comes from. And what a data structure is, it's just a way of arranging data in a way that you can pick apart later and get what you need out of it. So like an array is a data structure. It's a way of arranging a bunch of ints, a bunch of doubles. A vector is a data structure. Okay, there's more than that. Let's make our own. Let's make our own way of arranging data, all right? Let's make our own types, because that, at the end of the day, a type is where we put stuff, right? We hold one int in an int type. We hold a vector of doubles in that type, right? It's got its own name for what's inside of it. Let's make our own type and define what goes inside of it. That's the goal right now, all right? That'll allow us to make our own types, and a struct gives us that ability, all right? That's really, really cool and really, really powerful already, okay? Just a data type you make yourself, and you can put whatever you want inside of it. You can pick the types that are like deep inside of your outer type, and then you can like name all the stuff that's inside as well. So for example, maybe if you're making a video game, you'll want to make a point type to have like a 2-dimensional or a 3-dimensional point that would represent like where the enemies are, where the player is on the screen and in the game world, stuff like that. And then you want to like make variables like point P is where the player is right now, stuff like that. Like you want to make your own type that can hold X and Y and maybe Z coordinates, stuff like that. And then like you make whatever types you like and put whatever inside. Like make the blah type, and then here S is a variable of the type blah. And you can put little pieces inside. Maybe every blah variable needs an int, a double, a char, and a bool or something, and you can put those inside of every blah. That's the goal right now, all right? It'll make more sense with a real example. And everything that you can put inside of your types have names. So like S has a thing called X, a thing called Y, a thing called Z, and a thing called P. It's like boxes within a box, all right? And that's where we're going. And it's just stored all at once, kind of like an array. You're getting all of these things, these little inner boxes all at once by using S, all right? By using the name of your outer variable of your own type, okay? So in that way, it's similar to like a vector or an array in that you can have a bunch of stuff, but you can have names for the things inside, all right, which allow you to put multiple types as well. Like this, the X part of S could have been an int, and the Y part of S could have been a double. Did not have to be a bunch of ints, okay? So let's make that point struct. I think that would make it make the most sense. Let's make sure I don't have anything left to draw on the previous slide. Yes. So here, the point struct is a way to create a type that represents a point. All right, so here's kind of what I would like to be able to do. Make a point, and I can set it equal to like some coordinates, and like inside of every point, there should be an X and a Y coordinate. Let's make 2D points. All right, that'll be a struct that thinks about every variable of that struct's type will hold X and Y coordinates that I could use for a video game, for example. All right, that's pretty cool. And once I make a bunch of points, it'll be like just having one of those represents the idea of being at 2, 3. And you can make a bunch of other points at other places in the coordinate system, okay? So to make this type, to be allowed to do this, here's how you do it. You say struct, and then the name of your type, point, and then you put curly braces, and for a very weird reason, you put a semicolon after this one. I can explain that in office hours if you'd like. It's a weird rule. And then inside of the curly braces you put, and it's like you're declaring variables. You put what is inside the types and the names for every point, all right? So every point has a double X coordinate, so you just declare it, and a double Y coordinate. Double Y, semicolon, okay? And that, just by saying this, I have a brand new type now. It's called point, and I can make a bunch of point variables. Point P, point Q, and in between the curly braces, just very quickly, you can give all the things. Like just in order, you give the X and the Y, because you declared them in that order. Like this goes into the X, and that goes into the Y. Isn't that cool? Let's see. Do I want to go to code yet? Sure. Let's go to code just with that for now. we'll see that it compiles, but I haven't really shown you how to use your points too much yet. Structs.cpp. And so I would like to be able to do this, right? I want to say point p equals 2, 3. And so in order to have that type, I need to make the type with a struct declaration. So struct point, that's the name of the type. What goes inside of every point? X and Y coordinates, as far as two-dimensional points go at least. All right, so that's what I want. Every point should have an X and Y coordinate, all in one spot with those separate names. So double X, double Y, it's like you're just declaring them. And so now every single point that you make gets these inside of it. It has an X and a Y inside of itself. Isn't that cool? So like this point is representing the idea of being at 2, 3. And then I can make another one and be like point P2 equals, I don't know, 2.5, 3.5. And that will represent the idea, just in one place, of being this coordinate. Okay? So that's pretty neat. Let's talk more about that. All right, so I have new terms. After you make a type, you can make a bunch of variables of that type, and that like all these things are there at once. Let's talk a little bit more. All right, so there's new terms. Let's say object first. So I guess first of all, the struct, that's the name of the type. So I made a struct point, that's a brand new type, and now I can make a bunch of point variables. Specifically, we call those variables objects. All right, an object is a value of that type of your struct that you just made. So every point, that's my new type, every point thing that I make is called an object. P is an object, P2 is an object, we say. Okay, it's different from a normal variable. And so yeah, if I declare a point, I create a point object as a local variable. All right, that's what happens. And you can say it like this, point P semicolon, and that will just make X and Y hold garbage until you fill it with normal stuff. And then the pieces inside of every point will be called something, right? X and Y, those are the names we gave them. And we call those inner pieces of every object, we call those fields. So P has two fields called X and Y, and they hold doubles, okay? Another word for field is member or member variable, so those are interchangeable. All right, you can also say like P has two member variables that are both doubles, stuff like that. All right, so P and P2 are objects, their member variables are the X and Y that live inside of them, and you can totally declare empty points. You can be like point Q, semicolon, and right now it holds complete garbage that you will need to fill with something real before you use it, okay? So I guess now the question is, how do you go inside and get out the X and get out the Y, or set the X and set the Y, right? Because you don't want them to stay garbage all day long. Let's fix that. It's this dot thing. That's where it comes from. It means go inside of your object and do stuff to it. You've been using it this whole time, right, with other things. That's what it really means, right? It's like it accesses something. It goes inside, all right? So that's what's going on. It's an accessor, all right? So the dot operator goes in and gets your fields. All right, so every object has its own, like P has an X and Y, and Q also has an X and Y. They're all separate when you make them, and this P was made like this, where it's garbage. Point P semicolon, and Q was made in a better way. So yeah, to get at things, you use the dot, and I want you to think of the dot as like an apostrophe S. That will be helpful. All right, so to get at the X of P, you say P dot X. That's how you do it. To access your field name, you say the name of the object, dot, the name of the field you want to go inside of and access, and either get the value back or set the value. So like you could do this, p.x equals 42. Go inside of p, get the x member variable, and change it to 42, and it will do that. Or you could use it just by itself to get the value for you. So cout p.y will just go in and retrieve that value, okay? And like I showed you on this slide, you have some shorthand. You don't have to just start it at garbage. You could start it with the full thing if you give everything in order between curly braces. Just like, because you declared x and y in that order, the first thing will be set into the x, and then the second thing will be set into the y. That's pretty nice. So it's like an array kind of syntax, because you give it in that order, which is cool. And now I can show you some stuff. Now I can actually use points in a cool way. So let me give Q some stuff. Q.x can be like 4.5, and Q.y can be like 7.89, something like that. And then now we can print our points, right? Because we need the ability to go inside of those things, and now we have it. So let's print out our points in a pretty way with the parentheses and everything. So like p.x, print the x coordinate, and like comma space, p.y, the y coordinate. I think that'll do it, right? And then a new line. So that'll print my point. Hopefully in a pretty way. We'll see if I mess something up. Yeah, that's looking good, right? And you can do that for any point that you have. Like, print the q. Go inside, print the x and y for the q. All right, and so that's how you can go and change access and change things. Okay, so that's it. We're making our brand new types, and we can have it hold whatever we'd like. So it didn't have to be two inner member variables of the same type. It could have been different, but points, they both need to be doubles for sure. So I think what I would like to do next is just a bunch of examples. The cool thing, one new thing that you get from this, from having structs, besides the ability of like packaging things, is you get to return multiple things from a function in a different way now. You could do that with references. You could use a bunch of reference parameters to return multiple things, but because structs put a bunch of stuff in one spot, you can just return a struct from your function. Do you see that? That's kind of nice. So that will let you return, I guess if you want to return a point, you've suddenly returned two doubles at once. That's kind of cool. That's really cool. You have options now. So let's maybe make a function that adds together points, because it'll need to like return a brand new point that is their addition. Let's say that the sum, we'll define the sum on points like this. Like if we want to add this point to this point, the result should be a new point, and we'll just add up the individual coordinates. Like 2 plus 4, the new x will be 6. 3 plus 5, the new y will be 8. And so like you give it these 2 points, it will produce for you this third point. That can be an add function on points. Okay, let's do that. So it'll take 2 points and return a third point. And so it's really returning multiple things at once. That's neat. Yeah, so kind of here's how I want to use it. I want to be like, add p and q together, please. And then that will result in a brand new point that I can save away. Point, I don't know, p plus q is what I'll call it. There. And so then I can go off and print it out too. There. So let's make the add function. It's going to accept, right, 2 points and return a brand new point. So p and q, those are both of the point type. So those are the arguments too. So it's called add. It takes 2 points, point A, point B, and then it returns a third point. You can imagine just like vectors. I should probably be taking this by like constant reference, because I just want to use the values, not ever change them. But I'll just be lazy, have them be copied by value. That's okay for now. And yeah, so what I want to do, given 2 points, here's how I'm calling it down here. Given 2 points, A and B, inside of each there's x and y coordinates. I want to make a brand new point result, and fill in results x to be what? It's going to be the x and y, or I guess the x part is the sum of the 2 x's of those initial input points. So a.x plus b.x. So take the 2 x's and add them together into the result point. Yeah, same for the y. Add up the 2 y coordinates, put them into the results y coordinate. And then we've built up the point that we want to give back now. So return result. And that's how we'll do it. Okay, so I think that should work. It'll take the 2 points and add them back. So here's me using that down here. Boop. And apparently, right, 2 plus 4.5 is 6.5, 3 plus 7.89 is 10.89. It is working. So it took the 2 points, did not mess with them, took them as copies, and then it returned a brand new point. That was their sum coordinates. Cool. So there's that one. Let's use references now. Let's make a function that needs references. Let's make a function called negate point that negates a point in place. So I'll call it like this. I'll say negate point, and I'll give it a point p, and it'll take it by reference though. So it's just meant to be called on a line by itself. Just go off and do the thing. And so inside of p there was x and y member variables or fields, and right now it's set to 2, 3, but once this gets called it should go in, take it by reference, and mess with the x, make it -2. Mess with the y, make it -3, so negate the point. negate the coordinates of the point. Okay, so let me make that one for you now. Again, I like to just like use it first. Let's pretend we have it, and then that'll like inform the way that I implement it. So I would like to call it like this. I want to make a function called negate point where I can call it like this. It just takes p by reference and messes with it. And so now all the coordinates have been set to negative. So that's nice. All right, so let's go off and make it now. So negate point, what do we need? So it takes a point. Oops. Negate point should take a point. I'll call it A or something. And how do I want to mess with it? It should be void right now. Take a point, and I don't want it to be this way. I do not want it to be this way. I want it to take it by reference. Yes? Let's see, do I want to say it like that? Yeah, so it's going to take a point reference. And so A, like imagine the interfunction dreamland. Now when I call this, let me show you the call. When I call this, somebody's saying, like when we jump up to the body, point reference A equals P, and so now A will be, for the body, a new name for mains P. All right? And so what do I want to do with A? I want to take its x value and negate it. Take its y value and negate it. Yes? And so by messing with A, it's just another name for P because it was a reference. It will have changed P. And now when I print it again, instead of positive 2, 3, it should be negative 2, 3. Cool. Does that make sense? Please yell at me if you have questions about this stuff. But that's interesting, right? That's useful. We can make a function that negates an object in place. Takes the whole thing. I think it would be useful now to just draw a picture of the stack to remind us of what the stack looks like, because it's a little different when we have objects. There's boxes within boxes now. So let's talk about how negate point is working. When I call it, let's say we've made our way down to this line. We're about to run this line. Okay, so main is the very first thing that gets called always, and main makes plenty of things. It makes P, right? Main makes P on this first couple lines up here. And P has two member variables, x and y, that hold currently 2, 3. Yeah? 2, 3. And then we've got other things, right? We made Q. I just won't draw it all. I'll be lazy. We've got P2. These are all local variables to main, right? And then there's also P plus Q. P plus Q. Add it all up. Add it all in there. What else? What else? And then I think we're ready now to call negate point. So we're on this line. We're calling that negate point. And I'm going to draw everything that negate point owns in green. All right? I'm going to draw it all in green. Because when this call happens, of course, we make a stack frame for it. It's called negate point. But it doesn't make any memory of its own. And so I need colors for this reason. Negate point. Boop. And it's going to initialize this point reference A to be P for the duration of the body. And so A is just going to be another name for mains P like this. This is why I needed colors. So there's A as well. For the duration of negate point, A talks about this. It's messing with somebody else's memory. And so that's why when I mess with X and Y, for A, I'm messing with X and Y for P as well. It's the same thing. So that becomes negative 2. Boop. That becomes negative 3. And it seems like that's all that negate point does, right? Then we hit the curly brace, it returns, gives control back to main, the A goes away, and it's just P, but P has changed, all right? We've messed with that memory. I hope that makes sense. So that's why it works. And now I would like to ask you a question. All right, I'd like you to try this. Exercise for you. So here's our struct definition for points. Just like that. I'd like you to make your own struct definition now. Give it a try. Pause the video. Here's my question. Let me read it and explain it first. Here's what I want you to try. Please write a definition of a line segment struct. So make a type called line segment using struct. And what it will represent is a line segment, which is the following. Yes, so a line segment works like this. It's got 2 points inside of it. It's got a starting point and an ending point. Something like this. So this is what a line segment is. And do you see how you could represent the idea of a line segment by saving the starting point and the ending point of that line? Yeah, I hope that makes sense. That's the secret. So just like by saving those points, in memory, you're representing the idea that there could be a line drawn between them. So I'm not very good at drawing straight lines right now, obviously, but that's what I want. So please make a line segment struct that represents a line segment as starting and ending points, because that's one way that you could do it. That's one way that you could save in memory the idea of a line segment. Okay, so give that a try, and then I'll show you my way. Let's see here. So there's a couple ways that you could do it. I'm going to show you two of them, but let's see. The very first thing you need to do for sure is say struct line segment, yeah? And I cannot spell. Segment, and then open curly brace, closing curly brace, and don't forget this semicolon. It's weird. It's weird that it needs that there. It looks wrong, but it's necessary. All right, and then the question is what goes inside. So here's a couple ways to do it. I've got two ideas for you. You can see which one you did. So here's the first one. Let's call this one struct line segment. You could do it this way. You could be like, all right, every line segment, it's made up of a starting point and an ending point. And I know how to represent points like this. So I'll say, all right, double x1, double y1. That'll be the first point, yeah? And then double x2 and y2. That'll be the second point. And that could be one way that you represent a line segment, yeah? But I think that there is a better way. I think there's a cleaner way, because I've already taken the efforts, right? Took the time to make struct point already. That's another type, and I can put types within types. That's fine. So watch what I could do. Struct line segment, and like, all right, there's a starting point, and then there's an ending point. Point end. Do you see how clean that is? That's beautiful. I love that. And so now when you make a line segment ls or something, then what does it look like if you do it this way? What does it look like? It looks like this. Every line segment defined in that way has a thing called start, two-member variables, start and end. So some boxes, start and end. And then what does start and end look like? They are themselves objects, aren't they? That's fine. They're both points, and points are x and y's. So inside of start and end, I've got an x, and I've got a y. Do you see how that works? Interesting. And you might be wondering then, well, if I do it this way, how do I get at like inner pieces? Like if I wanted this, I wanted that y for the endpoint. How do I do that? Well, you just chain the dot. So ls dot, well, if I want to get here, right, I got to get to end first. So go to ls dot end dot y. Does that make sense? Dot y, something like that. And if I wanted the start one, how would I do that? It's ls dot start. Go to start first. Dot, give me the y out of that. So that would pick out this one. You see it? You can just chain the dots, because you're going inside of one object to get to this thing, and go inside of that same that inner object to get to the innermost double that lives in there. Okay, that's pretty cool. That's pretty powerful. And so I'll call this line segment 2, because you can only do it once. You can only say the name of a type once. You can't like redefine it. So I'll call this one line segment now. Point needs to be above it because it needs to know about points if I'm going to use them inside this inner type. So here, point. So every line segment has a starting point and an ending point, and those are just 2 points with inner x's and y's. Cool. And so now, let's see here. Honestly, maybe I should be making this in a separate file. Let's do that first. Let's do line segment.cbp. I think that would be a little bit better, because just keep the examples separate, maybe. So there's that one. You're going to need point. Let's get these over here first, though. And so in order to use that one, I need points. There. Whee! And so now when I make a line segment, here's how I can do it. I can say, well, line segment ls, and I can give it stuff. I can say ls.start.x equals something, ls.start.y equals something. Like I can give it x's and y's like this. I can say ls.end.x equals that, ls.end.y equals whatever that is. Okay, you can give it different values, and that's how you can fill in those innermost coordinates That's one way to do it. Alternatively, ls.start, that's its own point. So you could have done it this way, right? You could have said 2, 3 curly braces. That would have filled it in. And then finally, that would have been like a little bit faster. And then there's also a fastest way. If you think about it, like if this is what I want in start and end, those points, I can just do it in one line. Line, segment, I'll give it a different name though. ls2 equals, well, curly braces, and they start filling in each of the member variables. So there's, every line segment has a start and an end, so I need to give 2 things in these outer curly braces. So I put whatever I'm putting in the start, put whatever I'm putting in the end, and I want the start to be 2, 3, and that's a point. How do I make the point 2, 3? Well, it's more curly braces, 2, 3. And then same for the other one, 3, 4. Does that make sense? It's like, all right, here's the outer object, and then here's like inner objects inside of it being built up in the curly brace way. That's kind of neat, very useful. You can do it all at once. You don't have to do it in this long form way. It's up to you now. All right, so I think that's the example. I hope that makes sense to you. Please yell at me if you have any questions about any of that. But the whole point is structs give you the ability to make a brand new type, and you can put whatever you want inside of it. All those pieces, and you could get out each piece. All right. That finally leads us in to the idea of classes. And classes are super, super cool. They're very, very powerful. They give us the ability called object-oriented programming. They allow us to write object-oriented programs, and you may have heard that before. It's a very popular way of writing programs, and it's just built around making a bunch of these things called classes, which look very similar to structs. So that's why we started with structs. You get most of what you had in a class. You get most of what you had with structs, plus some extra secret sauce, right? So every class, when you make a class, it makes a brand new type just like a struct. It gives you data, like all the pieces of all your objects. That's all still the same. So just like structs, you get a way of talking about a bunch of data in one place. Just like struct, you get the idea of objects and member variables. But in addition to that, you get operations on yourself. There's like a concept of yourself. You have operations on the type itself. Operations live as part of the type itself. And so when you interact with your objects, you can kind of like ask it to do stuff for you. It's very interesting. So it's a cool metaphor, and people tend to like it. So it's used a lot in industry. And so here's kind of the idea. So let's think about like objects that can do things, because the metaphor for classes is like you're talking to all of your code as if it were in the real world, and it could understand you and could go off and do things for you. All right, so here's some examples of like real life objects that do things. Let's talk about their operations that we want to do on them and all the data that is stored inside of them. Yeah. So like we can make a PowerPoint class, not a struct. So it makes a brand new type. What goes inside of a PowerPoint is probably like a vector of slides or something, I don't know. Something like that. And then operations get to live inside of the type as well. All right, that's the new thing. So that like maybe there's an add slide operation for every PowerPoint object. So they can say lecture 14 dot add slide. See how you're running an operation? Like this is a function call. You're running an operation on the object. That is cool. It's like you're asking it to add the slide for you. That's very powerful and cool. Maybe there's like a dot save, dot other things, dot export, things like that. All right. You can imagine that animals you can model as types now. Like every dog, when you make a dog, what should it be allowed to do? It should be able to like do dot woof and make noise. Like cats too. Like you make a cat object for every cat you know in your life. So like my cat, maybe like the data that you want to associate with every cat is name and age, and like you can set the member variables as usual, and now you have member functions. All right, I'll explain that further, but like there's operations that you can ask your objects to do, like hey cat object, go and say meow. Yeah. And maybe like the birthday operation increments the age, stuff like that. All right, the eat operation increments the weight, something like that. So I hope that makes sense. That's where we're going. All right, and I hope you can see the power of this too. It's like you're asking these objects to do stuff for you, and it's kind of like you're talking to it, and that's good for us humans, because that's kind of how we break down problems. Like if I can do this, if I can delegate, have this other person do this thing for me, you can kind of do that delegation in a program now. So here, let's think about our running example of points. Let's turn points into a class instead of a struct. All right, because our goal in classes land is that in addition to holding like x and y coordinates, we want to be able to have the points talk to us and like understand our commands. So what do we want a point to be able to do? Let's think about it. So I'd like to be able to negate a point. Like I made that function already. Let's turn it into a member function. Let's have the ability to ask our point to negate itself. Hey P, go negate yourself. Does that make sense? And if you were to do it that way, do you see how you don't need any arguments? Instead of this one, like it took the point that way, but if you do it this way, it's like it's part of the thing, like it's before the dot, like you know which point you're acting on. It's like, hey P, go negate yourself. So there are no arguments necessary now. And then you can turn add into a member function, we say, by doing it this way. Like, all right, you say P dot, hey, go add yourself into some other point. So now it only needs one argument because it's kind of implicitly getting the first thing. It's like that's the thing you're talking to. That's the object you're talking to right now. All right. And then finally, you can maybe, like, here's a fun new one. Let's say that we can add a scale operation. You can ask a point to scale itself by a certain factor. So like here's kind of what I mean by that. If you say, hey point, go scale yourself by a factor of 2, that 2 means the following. So if your P looked like this, x and y, if it held like 1 and 2, by scaling it by a factor of 2, I mean take each coordinate and like double it now if it's by a factor of 2. So multiply each coordinate by 2. That becomes 2, that becomes 4. See it? And so in order to make this happen, you're just going to put a bunch of stuff in the type. So instead of struct, the first thing you do is change that to class. That's still the same. Class, the name of the thing now. That allows you to add these member functions. And then you still do that weird curly brace thing with the semicolon that I'm happy to talk to you about in office hours. It's a very weird rule. I just don't want to explain it here. It's a little silly. And then one other new thing that you add is you say public colon. I will talk about what that means. It just gives stuff access, because there's a weird different default for classes rather than structs. And so we want everything to be public. By default in structs it already is, but not for classes. And then you give all your normal stuff. So here's your member variables. And then you declare all of your member functions here. So what is, like, negate is an operation that's part of every point object. Like here it is. It takes nothing and it's void, right? Just call it on a line by itself, it does the thing. Same with the others. So like dot add. It's got a point already, so it needs just the one other one. You've already got yourself. Take the other one and then return a third point. That's what you're doing. Yeah. And then scale is kind of like negate. It's just like, hey, take yourself, go scale yourself by a certain factor. So you've already got a concept of yourself that you can mess with. The only other thing you need as your argument was that factor that you're scaling yourself by. Okay? I think that is what I wanted to say there. So we're going to go to code and talk about this soon. I do want to give you some new terms and just like write down the ones that I have already been saying. So a bunch of fun new terms. Cool. So a class, first of all, is just like a struct. It makes a new type. But in addition to that, it gives you the ability to write operations as part of that type as well. So they act on your objects, all right? It's like you're talking to them, asking them to do stuff for you. So that's pretty cool. That's the new thing that you get. And yeah, just like struct was the name of the type, a class is also the name of the type. So we're going to make a point class, and then object is still the word that we use for those values. So an object is a value of some class's type, just like it is for a struct's type. And so if we turn point into a class, you can still say point p semicolon, and point now would be the name of the class, and p will be the name of the object still. All right, so that's kind of how that works. And then fields and member variables, those are all still the same. Like you're still going to make x and y, you still call those fields, still call them member variables. And the new cool stuff is called member functions, as you might expect. Another word for that, though, is called method. So I'll say both interchangeably. So methods or member functions are the operations that live inside of your class. So here are my methods or member functions: negate, add, and scale. Those are the ones I'd like to add. And yeah, just in general, all this leads to object-oriented programming, or OOP for short. And it's just the idea of using classes as much as possible. Making a bunch of classes to do your stuff, and using those instead of just like normal non-objecty variables. and like asking them to go do work for you, like you're talking to them in the real world. That's a way of programming. It's object-oriented programming. I guess it kind of makes sense from the name, hopefully. So yeah, that's that. And now let's make this point class. I'll show you how. All right, we're going to do all these things. You can't forget the public. I will show you what that means. I'll write it down in a second. And then here's what you do, right? You're going to put your member variables inside. Don't forget the semicolon. Put the member variables. As usual, everything goes below the public right now, though. So you got that. And then you give all of your functions, too. All of your member functions, all of your methods. Okay? So there's that. And yeah, it's just all going inside the class because they're not normal functions. They are member functions. They're meant to be called with a dot, right, on the object itself. So it's talking about the object. And so let's see, how do I want to do this? Let me kind of draw what I want to have happen when I do these things. So here. It'll all still work the same as structs until you get to the member function stuff, until you get to the method stuff. So like if you say this, point p comma q, that'll make 2 point objects still. Now point is a class though. And so it'll give room for all of the member variables. So they each are going to have an x and a y still. Those are the 2 member variables that are part of every point that you ever make. That's what you've declared goes inside. And right now, they're all set to garbage. Like q is set to garbage, the x and the y, so is x. But then immediately here we're setting x and y of p to 1 and 2. So there's that one. And that's what it's going to look like. And what I want to have happen when I say something like p dot negate is, hey p, like you say, like you go to p and somehow it understands that you want it to negate itself. So it'll go run the code and mess with its own member variables. There's a way, all right? Make that -1, make that -2, yeah? That is the trick. And so we're just gonna give bodies to those things. And yeah, before we go to code, let me do explain public just very quickly. This implies the existence of private, by the way. We'll get to that. But what public does is it lets the user access the things down here. So it gives the user access. There's a concept of access control now that we'll get into later. It gives the user access to everything we put below it. To everything below, oops, it. All right, that's what it'll mean. So the user gets to say and talk about all of these things in like the main function. That's what I mean by that. So let's write this code and I'll talk about it. I guess I would like to make a brand new file called classes, and I'll steal a lot of this stuff. So classes.cpp, paste, and so instead of struct point, what we shall do is we'll say class point, all right? And then you say public, then you give all these things, and in addition to that, you give all of your methods or your member functions. And so instead of like point add, negate point, all these things like that, instead of doing it that way, let me just even delete these right now. Instead of doing it this way, we want this ability. All right, so instead of, let's see what I've got so far is that, those are all still work the same, still use the dot, but instead of this one, like add p to q, we're going to turn that into a method, p.add yourself to the other thing. So there's already a concept of you only need one other argument. Okay, so that'll do the add, then negate point will turn into, instead of this way, it's going to be p.go and negate yourself. That's what I want. It'll go mess with its own member variables. Okay, and then finally, let's have an example of this scale operation. So like, you ask, what's the other thing? Like q, the point q here, to go and scale itself by a certain factor of, let's say 2. All right, and then we'll print q's x and y out there. And that should do it. So that's how I want to use my class and ask it to do things for me. All right, so let's add all those pieces now. So I got negate, add, and scale with these types and these return types, these arguments. Let's add them all in. And boop. There's all those. And now I just need to give them bodies. And it is a little weird because these look like functions, I know, but they're really part of your point class, And so one thing that you get to do when you're making methods that you don't normally get to do with functions is you can talk about your member variables because it's part of a class. So when you're in here, like with negate, for example, when you're in here, you know that somebody called you, like you're part of the point class. Somebody called you on a point like this. And so you know that you have an x and a y just inside of you, kind of like your own global variables that are just yours only and nobody else's. So you can talk about x and y in here without ever having to declare them because they are already existing in you. All right, you can talk about yourself, if that makes sense. All right, so in here, I can talk about x and y, and they are the x and y that belong to the current object that negate has been called on. And that's really, really powerful because you could have called negate not on P, you could have also called it on Q, and when it jumps up, it knows which X and Y it's messing with. It knows, okay, I'm negating P or I'm negating Q because it's talking about itself. So you ask P to negate itself, it'll jump up here, it'll be P's X and P's Y. You ask Q to negate itself, it'll jump up here and it'll be Q's X and Q's Y if you just say the words X and Y. They all get their own, okay? So that means then, in order to implement this, I just say my x. You think about it as yours. Somebody has called negate, and they're asking you to do it for yourself. Negate yourself. How do I do it? Negate my x member variable, negate my y member variable. They exist because I am a method. Okay? Does that kind of make sense? That's the secret. That's how it's going to work. Okay? Let's see. Did I mess something up because it's like... Oh, sorry, this is supposed to be scale. That's why. Excuse me. That's why I was complaining. But that's how you call negate, and that's the implementation. And then add is very similar to our old add function. Instead of, here, let me steal what we had before. You're still doing it like this. That's still the body. You're still going to make a point result and fill it in with the stuff that you want. But now I'm going to say, in addition to taking the other point as... So first of all, you have your own. You have your own x and y, and you're adding that to the other's x and y. So that's why I called it O. So O.x, O.y. And I'm also going to take this other point that I'm adding myself into by constant reference, because I just want to access, right? I just want to access their member variables. I do not want to change them. O.x, O.y. And so when I call p.add on Q, you're going to jump up, right? What happens is it will jump up to the definition, jump up here. And then the x and y, when I talk about x and y, because it's p I'm asking about, x and y when I say it, it's p's x and p's y, and then q is going to be shoved into O there. So I'm getting it there and building up the new answer. Does that make sense? That's the secret there. And then finally for scale, it's just, all right, how do you scale something by a factor? You scale your own x and your own y by a certain factor. C, x times equals x times c, same with y. Y equals y times c. That will change your own member variables. And so when I ask Q to scale itself, it'll jump here, and saying X and Y are talking about Q's X and Y. It's acting on itself, all right? Not P's stuff, because I asked Q to do the thing, not P. So that should work. That'll do it. Here. We should get no difference in the output, except for that last line that's now like done something, right? We've scaled stuff. Oh, I've compiled. It would be helpful to compile the actual thing. Classes. There we go. So pretty much everything else is the same if you compare. And then this last one is that scaling thing. So that's the new one. But it all works still. All right, I hope you see the difference. Let me just scroll quickly through it. Here's the declaration of the class and the definition of all the member variables and the member functions. These are the methods. Oops. They're all there. Negate, add, and scale. You can always say the name of your member variable because you're acting on yourself. It's like whoever you got called on, whoever is asking to be negated right now, you're jumping up here, and it's their member variables that are alive right now. All right, nobody else's. So that's the deal. And yeah, here I am using those things. Add, negate, and scale. I hope that makes sense. So it's very similar. It honestly, like when you say dot negate, it's kind of similar to my example that involved references. So let me draw another stack diagram now. I'll show it to you. So let's say we've got now, instead, to this line, the p.negate line, it's this one. Let's say that we're working on that line right now. Let me draw the stack diagram again. Boop. So main, what did main have? It had p, x and y, that were set to 2 and 3. We had a q that held something, I don't remember. And then we had p plus q. We had other things, all right, da da da. So p is what we're about to act on though, so we're going to say p dot negate, all right? And once we see that, it jumps up to the negate body, and it does something cool, all right? So here, I'll use green again to talk about what negate is doing, because the name of the method is just negate. It is similar to a function. It's called negate, just some things are alive that aren't usually alive for normal functions. So we say negate, so we're up here now, and because we said p dot negate, if you say x and y, C++ has made sure to have you affect the x and y of the object you just got called on. So you say x, you're getting this x. You say y, you're getting this y. So that's why I needed green again. Does that make sense? Like, it's p that we're acting on, so that's the stuff that's alive right now. It's nobody else's member variable, it's p's member variables. It needs to act on itself right now, all right? And that's why now if I mess with those x's and y's, it's really changing p's x and p's y, -2, -3. See it? That's the secret. So that's what happens when you're implementing methods. The current object's member variables are the ones you get to see inside when you say x and when you just say y. It's really, you're getting at the member variables of that particular object that you're asking to do something for you right now. All right, so you get p's x when you call a method on p, like p dot negate, all right, and say x somewhere. So if you did q dot negate, you'd suddenly be acting on q stuff. Q dot scale was doing that. Q dot scale was jumping up and messing with q's x and q's y, because those are the ones that are alive when that gets called on q. You're asking q to mess with itself, all right? You're sending it little messages and having it respond to you. So that is actually a technical term. Another word for object-oriented programming is called message passing. So that's the metaphor. It's like you're sending your bidding to sentient beings that can do your bidding for you. Like, hey P, go negate yourself. Hey Q, go scale yourself. All right? It's always the current object's member variables that are alive right now. Okay? So I believe that is what I wanted to say for this example. I hope that makes some sense. Please yell at me if you have any questions. I know I've kind of swept this public idea under the rug. We're going to get there, though. It just means give the user access to everything below it. I'll show you the private, because you know that private must exist if we say public. I'll show you that next time. But the last thing I want to do today, then, is have you try something. I would like you to try, please, to make your own method inside the point class. I think that would be really, really helpful for you. So I'm going to give you all this code. You can get it, right? You can get it on Canvas. Take it and change it. Add some more stuff. Add another method, please. Add a couple more methods if you want to. Here are some ideas. Have the ability, maybe, this is the most glaring problem right now, like, this should be abstracted away into a method, shouldn't it? This printing idea, like, hey P, go print yourself. Hey Q, go print yourself. Print. Make a print method. That would be useful. They can replace that. Some other ideas would be like, you could have it reflect itself across the line y equals x. So like, if you had this point, dot reflect could swap the x and the y, and it kind of mirrors it across the coordinate system over to here, for example. You could do that one. Another option is you can have, this would give back a new point, or sorry, this could mess with the same point. And then maybe you can have a function or a method, a member function, that gives back something as well. Like, these are void. Let's make one that actually gives something back. A good example would be something like p dot, give me back the distance of this point to the origin, which is 0, 0. So the distance between the current points, x and y, to 0, 0. And then you can like use that to do math or print it out, something like that. That would involve like square roots and things, right? Square roots and squareds and addition. So look that up if you're interested, but those are some ideas for you. I won't show you these answers. I would like you to try them, okay? Pick one at least and give it a try. That's a great way to practice and to learn. And I'd be happy to look over your code to confirm that it's working. I think that you could also probably figure out how to test it too, but I'm happy to help as well. If you're struggling with anything, please ask me lots of questions. And with that, we have made it to the end of this first lecture on classes and structs. So I don't want to go any further than that because I know it's a bunch of new stuff, but it's very, very powerful. I hope you can see like the abilities that you get just with structs even, and then the extra stuff that you get with classes on top of that. It's really, really cool and really, really powerful. And I have more to say about it, but we'll have to wait until next time. So I will see you then.